All right, let's go.
Number 10. Kepler 442b, the most Earth-like planet we found early. In 2015, NASA's Kepler Space Telescope confirmed a planet that immediately jumps to the top of every habitability list. Kepler 442b, 1,206 light-years away in the constellation Lyra. Roughly 1.3 times the size of Earth, orbiting a K-type orange dwarf star, cooler and smaller than our Sun, but more stable and longer-lived. Its orbital period is 112 days, placing it comfortably within its star's habitable zone. The numbers that matter most are the similarity indices. The Earth Similarity Index, a composite measure of radius, density, escape velocity, and surface temperature, gives Kepler 442b a score of 0.84 out of 1. Earth scores 1.0. Mars scores 0.64. Kepler 442b is more Earth-like than any other confirmed exoplanet discovered in the first decade of the Kepler mission. Its star is about 4,000 degrees Celsius, cooler than our Sun at 5,500 degrees. That means the habitable zone sits closer in. But the reduced stellar activity compared to younger, hotter stars means the planet's atmosphere, if it has one, faces less bombardment from harmful radiation. The estimated surface temperature, assuming an Earth-like atmosphere, is around -2.3 degrees Celsius. Cold, but within range for liquid water, especially with greenhouse warming. We do not know if it has an atmosphere. We do not know its composition. We cannot yet image it directly. What we do know is that its size, orbital position, and stellar environment make it one of the most promising candidates we have found. At 1,206 light-years, it is not somewhere we're visiting anytime soon, but it is somewhere worth pointing our best telescopes. Number 9. TRAPPIST-1e, the best chance in a system full of chances. The TRAPPIST-1 system announced in 2017 stopped the scientific world for a reason. 7 Earth-sized planets orbiting a single ultra-cool red dwarf star. 3 of them, TRAPPIST-1e, F, and G, sitting in the habitable zone simultaneously. 3 potentially habitable planets around one star, 39 light-years away. TRAPPIST-1e is the standout. Of all 7 planets, it receives the most Earth-like amount of stellar energy, about 66% of what Earth receives from the Sun. Its size is almost identical to Earth, 0.92 Earth radii. Its density suggests a rocky composition. Its orbital period is 6.1 days, fast by our standards, but the star is so dim and cool that the habitable zone sits extremely close in. James Webb Space Telescope observations of TRAPPIST-1b and 1c, the innermost planets, were published in 2023. The results were sobering for 1b and 1c. No thick carbon dioxide atmosphere detected, suggesting they may be bare rocks. But 1e is further out, different conditions. The Webb results on the inner planets do not rule out atmospheres on the outer ones. The concern with all TRAPPIST planets is the star itself. TRAPPIST-1 is a red dwarf. Red dwarfs produce intense flares, ultraviolet and X-ray bursts that could strip planetary atmospheres over geological timescales. Whether TRAPPIST-1e has retained its atmosphere despite billions of years of stellar activity is the central question. If it has one, and if that atmosphere is anything like Earth's, TRAPPIST-1e is potentially habitable right now, tonight, as this video plays. Number 8. K2-18b, the water world with a warning label. K2-18b is 124 light-years away in the constellation Leo. It is not Earth-like. It is roughly 8.6 times Earth's mass and 2.6 times Earth's radius, placing it in the mini-Neptune category. So why is it on this list? In 2023, James Webb Space Telescope data revealed the presence of carbon dioxide and methane in K2-18b's atmosphere, and something else. A tentative detection of dimethyl sulfide, a molecule that, on Earth, is produced almost exclusively by marine phytoplankton, by living organisms, by life. The detection is tentative. It needs confirmation. The signal is at the edge of Webb sensitivity. Multiple follow-up observations are underway, and results as of 2026 have not yet confirmed or ruled it out definitively. But the scientific community took it seriously enough to publish it and to prioritize follow-up observation time. K2-18b is thought to be a Hycean world, a planet with a hydrogen-rich atmosphere covering a global liquid ocean. No land, just ocean under a thick hydrogen sky. Life in such an environment would be radically different from anything on Earth, microbial, ocean-based, possibly chemosynthetic rather than photosynthetic. The dimethyl sulfide signal may be a false positive. Abiotic chemistry could potentially produce it in conditions we do not yet understand. But if it is real, K2-18b is the first planet outside the solar system where we have detected a potential biosignature. The first. Number 7. Proxima Centauri b, the closest one. 4.24 light-years. That is it. The closest star to the Sun has a planet in its habitable zone. Proxima Centauri b was confirmed in 2016. It orbits Proxima Centauri, a red dwarf, at a distance of 0.0485 astronomical units with an orbital period of 11.2 days. It receives roughly 65% of the energy Earth receives from the Sun, placing it in the habitable zone. Its minimum mass is 1.07 Earth masses, essentially Earth-sized. Rocky almost certainly. The problems are real and significant. Proxima Centauri is a violent star. It produces flares of extraordinary intensity, X-ray and ultraviolet bursts, thousands of times more energetic than typical solar flares hitting our planet. In 2016, a superflare was detected from Proxima Centauri, an event so powerful that if Earth were in Proxima b's position, it would have received 4,000 times the radiation of the most powerful solar flare ever recorded hitting our planet. Proxima b almost certainly does not have a global magnetic field strong enough to withstand that bombardment continuously over billions of years. Its atmosphere, if it ever had one, may be gone. But red dwarfs have been producing these flares for billions of years. If life emerged on Proxima b early enough and went underground or underwater, below a protective layer of rock or liquid, it could potentially survive the surface bombardment. The other reason Proxima b belongs on this list is proximity. At 4.24 light-years, it is the only potentially habitable exoplanet we could conceivably visit with current theoretical propulsion concepts in a human-scale timeframe. Breakthrough Starshot, the laser sail project, targets Proxima Centauri specifically. If life exists anywhere outside our solar system and we ever make contact, Proxima Centauri b is the most likely place that story begins. Number 6. TOI 700d, the one NASA found with TESS. TOI 700d was confirmed in 2020, one of the first Earth-sized planets in habitable zone discovered by NASA's TESS mission, the transiting exoplanet survey satellite that succeeded Kepler. It is 101 light-years away in the constellation Dorado, 1.19 times Earth's radius, orbiting an M-dwarf star, a small, cool red dwarf with an orbital period of 37 days. It receives about 86% of the energy Earth gets from the Sun. Two potentially habitable planets in the same system, 101 light-years away. TOI 700d is particularly valuable scientifically because its host star is well characterized and relatively quiet, less flare activity than many red dwarfs. This gives any atmosphere a better chance of surviving. James Webb has observed this system. Results from those observations are being analyzed and will shape our understanding of what these planets are actually like. The TOI 700 system is one of the primary targets for next-generation direct imaging telescopes being planned for the 2030s. If we ever get a photograph of an exoplanet's surface, a pale blue dot around another star, TOI 700D or 700E are candidates. Number 5. Kepler 452b, Earth's older cousin. NASA called it Earth's cousin when they announced it in 2015. That framing was slightly overcautious. Earth's older twin might have been more accurate. Kepler 452b orbits a G-type star, the same spectral class as our Sun, not a red dwarf, a Sun-like star. It orbits at almost exactly Earth's distance from its star, receiving about 10% more energy than Earth receives from the Sun. Its orbital period is 385 days, almost exactly one Earth year. Its radius is about 1.6 times Earth's. That puts it at the upper edge of what is likely to be a rocky planet. Above roughly 1.5 Earth radii, planetary composition becomes uncertain. It may be rocky, it may have a thick volatile envelope. We do not know. What makes Kepler 452b haunting is its star's age. The host star is approximately 6 billion years old, 1.5 billion years older than our Sun. If Kepler 452b is rocky and habitable, it has had 1.5 billion more years than Earth had at our current stage of development. 1.5 billion years. On Earth, that is the difference between single-celled bacteria and complex multicellular life, between microbial mats and dinosaurs, between nothing visible to the naked eye and ecosystems of extraordinary complexity. If life followed a similar trajectory on Kepler 452b, whatever is there now has had 1.5 billion more years to develop than we have. It is 1,400 light-years away. We cannot see what is there. We can only note that if the conditions are right, the head start is enormous. Number 4. LHS 1140b, the quiet one with the best atmosphere odds. LHS 1140b does not get the attention it deserves. It is 49 light-years away in the constellation Cetus, 1.73 times Earth's radius, about 5.6 times Earth's mass, dense enough that models favor a rocky composition with possibly a significant water component. It orbits an M-dwarf with a period of 24.7 days and receives about 43% of Earth's solar energy, on the cooler end of the habitable zone but within range. What makes LHS 1140b exceptional is its host star's behavior. LHS 1140 is one of the quietest, most inactive red dwarfs known. Minimal flare activity, a relatively stable radiation environment. This dramatically improves the probability that any atmosphere on LHS 1140b has survived billions of years of stellar exposure. James Webb observations of LHS 1140b published in 2024 produced a result that generated significant attention. The data was consistent with the presence of a nitrogen-rich atmosphere, similar to Earth's. Not confirmed, consistent with. The signal could also be explained by other scenarios, but the result was strong enough that LHS 1140b was immediately elevated to one of the top targets for further atmospheric characterization. A nitrogen-rich atmosphere on a rocky planet in the habitable zone of a quiet star, 49 light-years away. If that result holds up under continued observation, LHS 1140b moves from promising candidate to the most compelling habitable world beyond our solar system. Number 3. Wolf 1061c, the one that is probably habitable right now. Wolf 1061c is 13.8 light-years away, close enough that if we developed a spacecraft tomorrow capable of 10% light speed, it would arrive within a human lifetime. It orbits Wolf 1061, a red dwarf, with a period of 17.9 days. Its mass is at least 4.3 times Earth's, a super-Earth. It sits in the inner edge of the habitable zone, receiving perhaps slightly more radiation than is ideal, but within the range where liquid water could exist on the surface, depending on atmospheric composition and reflectivity. A 2017 study found that Wolf 1061c's orbit is significantly less stable than Earth's, varying more over geological timescales in ways that could produce dramatic climate swings. Earth's orbit is stabilized partly by the Moon's gravitational influence and partly by Jupiter's. Wolf 1061c may not have equivalent stabilizers. Dramatic orbital variation could mean alternating between extreme heat and extreme cold over long cycles, potentially driving evolutionary pressure if life exists there, or potentially sterilizing the surface repeatedly. But 13.8 light-years is astonishingly close. If any of the planets on this list were ever to be visited by a human crew or a fast robotic probe in the next few centuries, Wolf 1061c is one of the most accessible. Number 2. Teegarden Star B, the overlooked gem. Teegarden Star is 12.5 light-years away, one of the closest stars to Earth. It is an M-dwarf so dim that despite its proximity, it was not even discovered until 2003. In 2019, 2 planets were announced orbiting it, Teegarden Star B and C, both in the habitable zone, both roughly Earth mass. Teegarden Star B has an Earth similarity index of 0.95, the highest of any confirmed exoplanet at the time of its announcement. Higher than Kepler 442b, higher than every other planet on this list in terms of raw similarity score. It orbits with a period of 4.9 days, tight around its dim star, but receiving approximately the same energy flux as Earth receives from the Sun. Its minimum mass is 1.05 Earth masses, essentially Earth. The challenges are familiar. It orbits a red dwarf, so flare activity is a concern. But Teegarden Star is an old star, estimated at 8 billion years old. And older red dwarfs tend to be less active than younger ones. The flare threat may be more manageable than for younger systems. At 12.5 light-years, Teegarden Star B is close enough that the square-kilometer array, the massive radio telescope network being built in Australia and South Africa, could potentially detect radio emissions from a technological civilization there, if one exists. A planet with an Earth similarity index of 0.95 at 12.5 light-years, it barely gets mentioned outside specialist circles. It should be a household name. Number 1. Earth. The only one we know works. Here is the uncomfortable truth that sits underneath every planet on this list. We have found dozens of potentially habitable exoplanets, hundreds of candidates. We have measured their sizes, their masses, their orbital parameters, their stellar environments. We have detected molecules in some of their atmospheres. We have confirmed life on exactly one of them, Earth. And Earth is extraordinary in ways we are only beginning to fully appreciate. The Moon, large enough to stabilize Earth's axial tilt, preventing the dramatic climate swings that would otherwise make long-term, complex life difficult. Jupiter, massive enough to act as a gravitational shield, deflecting many large impactors that would otherwise hit Earth. The magnetic field, generated by our liquid iron core, deflecting solar wind and cosmic radiation continuously for billions of years. Plate tectonics, recycling carbon and maintaining the long-term carbon cycle that keeps surface temperatures within bounds for liquid water. Every planet on this list might have none of those things, or all of them. We cannot yet tell. The search for life on exoplanets is really a search for another Earth. Not just the right size and distance, the right history, the right companion objects, the right interior, the right star at the right age behaving in the right way. The more we learn about what made Earth habitable, the more extraordinary it seems that it happened at all. And the more urgently it matters that we take care of the one confirmed habitable planet we actually have. 10 exoplanets that could actually have life.
From the quiet red dwarf systems close enough to visit within centuries to the sun-like stars with 1.5 billion year head starts. From the ocean world with a possible biosignature to the closest one at 4.24 light-years that we could theoretically reach. We do not know if any of them have life. We do not have the technology yet to know for certain. But we are getting closer, and the universe is large enough that the question is not whether life exists out there. The question is whether we will be smart enough and patient enough to find it. Thanks for the love and support. It genuinely means a lot. Subscribe to Cosmichives. See you in the next one.